So, welcome to the Learning Express YouTube channel. So, in this video, I'm going to continue common source amplifier with a source degeneration resistor. So, here we are going to calculate the voltage gain using large signal model. So, for the large signal model calculation, I'll derive the expression for ID, RD. So, for the small variation, this is the ID. So, for the small variation, in this output voltage, that is a differentiation with respect to input voltage, that is nothing but a small signal voltage gain is equal to minus del ID by del V in multiplied with RD. So this term is nothing but GM minus GM RD. And this capital GM is nothing but transconductance due to this degeneration resistance. It is not equal to GM. This GM was simply, previously it was like 2ID by V over drive. So this is the different GM, and this capital GM is different. It is due to the source degeneration resistor. So now the point is how to calculate this GM. So this GM is del ID by del V. And we know that this ID is nothing but a function of VGS for the transistor M1. So we can say that del ID by del V in can also be written as like del ID by del F, or you can say not del F, but it is del VGS. So I should write here del VGS. So it is a del VGS, and now this is del VGS by del V. So we know that this del ID by this del ID by del V. Okay, it can be written as del ID by del VGS and del VGS by del V in. So this VGS is equal to V in minus ID RS. From KVL here, this is your VGS, this is your VGS, and this is your source potential is IDRS. This is your IDRS. So yeah, VGS equal to V in minus IDRS. So del VGS by del V in equal to 1 minus del ID by del V in RS. So put this expression in this equation. So if I say this equation 1 and this is equation 2, this is equation 3. So put this value of equation 3 in equation 2. So we will get del ID by del V in, which is nothing but equal to capital GM is equal to 1 minus. So yeah, del ID by del V in is capital GM. So GMRS multiplied with del ID by del VGS, or IG is a function of VGS. So this is nothing but a small GM. So this is a small GM. So from this expression, we can obtain, okay, I'm calculating here. From this expression, I have GM equal to 1 minus GMRS, this capital GMRS into small gm. So it can be written as like, we can separate capital GM from here. So capital GM is GM divided by 1 plus GMRS. So this was our motivation how to calculate capital GM. Now, if capital GM is obtained, put it here, and we will get the expression for gain. It is GM 1 plus GMRS times RD. So this is the final expression of gain using large signal model, where I used the DC equation V out equal to VDD minus IDRD, and then I applied this differential change over this V out, that is nothing but del V out by del V in. And from here, we calculate the large GM, which is nothing but the transconductance due to this source degeneration. And after that, I represent this capital GM in terms of small gm. and later we put this value in the equation 1, and hence we obtain the value of voltage gain, small signal voltage gain. Actually, this is the last signal analysis where we use the DC equations, but we are obtaining this change in output with respect to change in input. This differential change is nothing but a small signal voltage gain. So I think this is enough for this video. In next video, I'll tell about the small signal model and then intuitive analysis for gain calculation. So thank you.